Hi guys, it's Ru the tutor here, your maths hero. So today I'm going to be taking you through a paper. So the paper I'm going to be taking you through is the NCEA for 2017. Let me just quickly show you guys the paper. So the paper I'm going to be taking you guys through is the NCEA qualification. I'm going to be taking you through the level 2. So it's going to be 91262, and we apply calculus methods in solving the problems, and it's a 2017 paper. So I'm going to take you guys through question number 1 for this video. So I'll just create a playlist with each of the questions consecutively, but yeah, that's what I'm going to be doing. Okay, so without any further ado, let's get into it. Okay, so for question number 1, what we have is we have a function f given by f of x is equals to x to the power 5 plus 3x squared minus 7x plus 2. So what we've been asked to do is to find the gradient of the graph of the function at a point where x is equals to 1. Okay, so let's try and visualize what this graph could look like. So we've got our x here, right, and we've got our y, right. Oh, good Lord. And we've got our y, right? And then, so what we're going to do is it's most probably going to look something, something like this, for example. And let's say we have our point. Okay, let's say it keeps going like this. And let's say we have our point here, right? We've got our point here, right? And let's say this is equal to 1, right? This is our point 1 here, right? And well, x is where x is equal to 1, and we've got our tangent here. So we want to find, for us to find the gradient of the graph at this point, we draw a tangent. And the gradient of that tangent is the tangent at this point where we know x. We don't know what y is. Could be any number, but we can find y if we like, but we don't know what y is. So we'll just say y is equal, let's just say y, we'll just say y1, y not y1, right? y1, that's our y, and this is our x, and we've been asked to find the gradient, right, at this point. So what do we do when we're dealing with functions like this and we've been asked to find the gradient? Okay, so to find the gradient at any point, right, for this graph, what we do is we differentiate this, right, and whatever we find is the derivative, if we substitute in x, we find the gradient at this point, right? So that's very simple. So what we're going to do is we want to find f cap of the function f, which is the derivative, right? So f cap of x, right? So what's that going to be? So if we differentiate 5, we bring the 5, so it becomes 5, right? So what we do is we take the 5 and we multiply by the expression, and then we subtract from the exponent, right? So it becomes x to the power 4, right? And then for this character, it becomes 3 times 2, which is equal to 6. So it's going to be a plus here, so it's going to be 6, right? And then obviously there's going to be a minus 1 here. So there's going to be a minus 1 here. So 2 minus 1 is 1. So then we just write that as x, right? And then what else? We've got minus 7, right? So here there would be a 1. So the 1 will just multiply the 7 and it would remain 7. And then would have a minus 1 here. So 1 minus 1 is 0. X to the power 0 is 1. So we just have a 1. The 2 disappears because if you differentiate an integer, it's always going to be 0. Okay, so this is f cap of x. This is the derivative of the function here, this function here, right? So what we then do is now we substitute 1, right? So f of x, right, or f of 1, let's say, right, f of 1. Let me just quickly rub that. I don't know, I think I was about to write x because I'm just so used to dealing with x and x's. Okay, so what are we gonna do? Get my pen back, and then click on. Okay, it's on now. Which is equal to 5, right? 1 to the power 4, right, plus 6 multiplied by 1 minus 7, right, which is equal to 4, right, because it's going to be 5, right, plus 6 minus 7, right, which is equal to 4, because that's 11 minus 7. If you add 5 plus 6 is 11. 11 minus 7 is 4, right? So this is your gradient m. M is equals to 4. Simple. I think that's all we need to do. And this question 1a is done. So let's move on to the next question. Okay. So for the next question, it's find the equation of the tangent for the graph. Okay, find the equation of the tangent to to the graph of the function f of x is equals to 6 plus 14x minus 2x cubed at the point 218. So we know this is our x coordinates already, right? This is our x and this is our y. Simple, right? And we want to, like I said before, we have our graph, our cubed graph. So probably look something like this. So it looks something like this for argument's sake. And this is our point. Let's say it's a 2 here, right? This would be our point 2. Let's say it's 18 here, right? Ish, that 18 looks terrible. And then we've got our tangent here. So we want to find out what is the gradient of this. In a sense, we want to find out what the gradient of this is, right? So what do? We differentiate our function. As we've been doing, we differentiate our function so that we can find what the gradient, so that that becomes our gradient function, and whatever we substitute x in is the gradient of this tangent. So that is the concept that we're dealing with. I hope that's very clear. I don't want to spend too much time. I think I've explained this in multiple videos. I'll link the videos that I've explained the concept in depth, but I'm not going to go through it because this is more revision of a test paper. It's not me trying to actually teach you anything new. I'm just trying to teach you the concept. So that is the concept we use. If you do not understand the concept, I do have content on this concept, and I'll link it in the description. Okay, moving on. So what do we have now? Okay, so we differentiate this. How do we differentiate this? What we'll get for f cap x, right? F cap x is going to be equal to 14 minus 6x squared, right? And then we substitute what is f cap of 2. That's going to be 14 minus 6 and 2 squared, right? What is 2 squared, right? So it's going to be 14, right? Minus 2 squared is 4, 6 multiplied by 4, right? Which is 24, right? So 14 minus 24 is equal to 10. So it's going to be equal to minus 10. That is our m, right? And then here is the tricky part, right? So we know, right, our gradient equation, right? So our gradient is changing y over changing x, right? So if we have 2 points, right, our gradient is y, right, minus y1, right, over x, right, minus x1, right, is equal to m, right, which is our gradient. So if we use this equation, we already know what y1 and x1 is from here. This is y1 and x1, we already know, right? Can use that as y1 and x1, and then we can have our gradient function. So what I would do is I'll just simply substitute this to find my equation, right? So we can say y, right, minus, what's our y, 18, right, over x, right, what's our x1, 2, right, is equal to m, right? Then this can cross multiply, then it becomes y, right, is equal to 18, right? M is minus 10, right? Oh, good lord. It's not y is equal to y minus. Hold on, let me just rub this so that it makes sense. Oh, my bad. Don't know where I'm getting y equals to. I'm getting lost in the source. So it's just supposed to be y, right? Y minus 18 then becomes equal to minus 10, right? Multiplied by x minus 2, right? And when we simplify this, I think I'm running out of space. When we simplify this, it becomes y, right? Minus 18 is equal to minus 10x, right? Plus 20, right? And then 18 comes, so it's a very ugly 20, right? Plus 20, right? And then simplifying this, right? Simplifying this, what we then get is equal to y, right? Is equal to, the 18 moves to this side, right? And then it becomes a plus 18. So it just becomes y minus 10, our gradient, x plus 38. Simple. This is our solution. And that is what we do for number 1b. So let's move on to number 1c. Moving on to question 1c, okay, as we can see here, it looks like we've got an equation of moment, so most probably need to carry out some calculus to find what we're looking for, okay? So the question goes like this. The movement of an object is recorded from the time it passes a fixed point. After t seconds, it has a speed of v meters per second, which can be modeled by the function v of t is equals to 0.5 t squared minus 2t plus 1. Use calculus to find how long it takes to reach an acceleration of 2.85 meters per second squared. Okay, so what do we know from our equations of motion? Okay, so from our equations of motion, right, we know that velocity is the time derivative of distance, and acceleration is the time derivative of velocity. Okay, so what I'm saying is, from our basic knowledge of mechanics, all right, of some of our basic knowledge of the motion of mechanics or Newtonian mechanics, right, what we do know is, right, hold on, dx, right, dt, right, is equal to v, right, and we know that dv, right, dt is equal to a, right? So we already have a term in terms of v. All we need to do is differentiate, right? So what happens if we differentiate this function, right? So v, right, t cap, right, is equal to the 2 times the 0.5, right? What is 2 times a half? That's 1, right? And then we're just left with t, right? Because we subtract the exponent minus the 2 falls off, and then we've got, the t falls off, sorry, and then we've just got a minus 2, right? So in a sense, we're saying acceleration, right? Because like we've said here, dv dt is equal to a, so which is the same as saying this is equal to a, right? So we're saying acceleration is equals to t minus 2, right? And we want to find the time, and we've been given the acceleration. So we come substitute acceleration here. So we're saying 2.8, right, is equal to t minus 2, right? So we're saying 2.8, right, plus 2 is equal to t, right? So let me try and write that better. 2.8, right, plus 2 is equal to t, right? Therefore, t is equal to 4.8 seconds. Don't forget the units. Don't ever forget the units. Seconds. That's done. And this is how you go about it. So it's just remembering your basic Newtonian mechanics, in a sense. Okay, I think that's done. Let's move on to D. Okay, so 1D goes like a tangent to the graph of a function f of x is equals to 3x squared minus 4x and has a gradient of 2 and passes through a point 5a where a is a constant. Find the value of a. Okay, so how do we do this? How do we find the value of a? Okay, so we already know our gradient is equal to 2, right? That's what we already know. And this is our function, right? So what we know is the derivative of this function, right, is equal to 2. As we've been doing in the previous questions and from our first principles, right? So what we do know is that 6, right, x, right, minus 4, right, is equal to 2. Great. Which is equal to, right, what do we want to do here? What we want to do is we want to find out what x is, right? We want to find out what x is. Why do we want to find out what x is? We want to find out for what value, right? Do we, because we want to find out for what value of x, right, do we get the gradient of 2? So for we want a range of values of x, right? We want a range of values of x, because, well, the trick in this question here is what we're not saying is if you substitute uh 5 into here, right, you're gonna get 2. That's not what we're saying. What we're not saying is the gradient is 2 at this point. No, 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 no. What we're saying is this function has a gradient of 2 and it passes through. This is a whole other point along. Okay, so this is why I like to draw things and visualize. So let's visualize this first before I continue going, because I think that's where most learners get lost, right? So what we're saying is we have our graph, right? Let's draw a graph. So this is an x squared graph, so it should be easy. So we've got our graph. It's like this. Say it's an x squared graph. So let's say it looks something like this. Let's just assume it's like this. Right? It's an x squared. Right? What we're saying is, right? When let's say we've got a gradient here, right? Or going to say this is our gradient here, right? We're saying at this point, right? Our gradient here is 2, right? And we're also noting that there's another point, right? Let's say another point discuss another point up here. For this point up here, right? This point is 0.5 and we don't know what A is. This is what this question is saying. This is what you need to be able to visualize, right? You need to be able to visualize. So this is what this question is saying, right? So what I'm doing is I first want to find out what the value of x is here, where this is what I want to find out what this is here, right? That's why I'm doing this, or that's what I'm trying to find out the value of x is here. Then I'll find out, and then I'll find out what y is after I know what x is. I hope this makes sense. Okay. Okay, and passes through a point. No, 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 no. I'm actually getting lost. So the point 5a, right, should be somewhere up here. Right? Let's say this is 5a. Yeah, this is point 5a. So this would be, my bad. So I got a bit confused. So no, 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 no. This is not 5a. 5a is not along the graph. 5a is along this line. So we're saying at this, right? So this would be 5, right? This point here. This would be our 5 here, right? Our 5, and this is a, right? So this is 0.5a, right? So we've been asked to find the gradient. So what do we do? Very simple. First, we find out what x is at this point. How do we do that? We differentiate, and then what do we get? We get our 6x, right, minus 4, right, is equal to 2, because that's the gradient at this point, which is equal to 2 plus 4. Got our 6x, which is equal to x. So x is equal to 1. We now know that x is equal to 1 here at this point, right? Okay, we know what x is at this point. Okay, so what are we trying to do? So we know what x is, right? At this point, we now know what x is, right? Okay, we found out what x is. So what do we? How do we move on now that we found out what x is? Now we want to find out what y is, right? So for us to find out what y is, we have our function here, right? So we can find out what y is when x is equal to 1. So what we want to do is we're going to substitute into this function. So if we substitute into this function, what do we get? We get f of 1, right? It's just going to be equal to 3, 1 squared minus 4, the 1 here, all right? And this is going to be equal to minus 1. So we now have our x and we have our y, right? Then now we can go back to remember our equation. We have our gradient 2. We can go back to our equation y, right? Minus y1, right? Equals to m, right? Or y minus y1 over x minus x1 is equal to m, right? We have our y1, right? Our y, so yes, we have our y1, we have our x1, right? And we can create an equation. Once we create this equation, we can now find out what the equation of this line is. Then once we find out what the equation of this line is, we can just substitute our value for x, which is 5, and find out what a is. Okay, so how do we do that? Okay, how we do that is now we're going to create our equation for this line, right? The equation that creates this line. So we substitute in like we did before. What? So we're gonna say y minus minus 1, right, is equal to, what's our m? Our m is 2 multiplied by x minus 1, right? If you simplify this becomes y plus 1 is equals to 2x, right, minus 2, right, which is equal to y is equal to 2x minus 3, right? This is our equation, right? Now what all we need to do is substitute x into this to find out what y is. So y is equal to 2, right? We put in our 5. So we're going to substitute this 5 into here, into this equation, right? Minus 2. Oh, minus 3, sorry. Right, so it becomes y, right? 10 minus 3. So y is equal to 7, and which is also equal to a. Simple. Okay, not simple. So this was a very complicated question. Extremely complicated question. So yeah, please, go through it again, try and understand what I'm trying to get at. But it's just an issue of you need to understand what they're asking. You need to understand the English. So this would be your literacy. So you need to be able to understand what the examiner is asking, and then you'll be home and dry. Hi guys, so let's move on to our last question, which is question number 1e. So the question goes like, the function f of x is equals to x cubed plus a x squared plus bx plus 2, and as a turning point when x is equals to minus 1 and when x is equals to 3, find the values of a and b. Okay, so if it has a turning point, right, at these 2 points, what does that mean? It means that the gradient is 0 at those 2 points. Agreed? That is what that means. Okay. So what we can do, so we've been asked to look for 2 values a and b, right? This is our objective. But from our information, we know that at point minus 1 and at point 3, the gradient is equals to 0. So what we can do, given this information, is we can create 2 simultaneous equations and solve them to find a and b. Okay, so how do we do this? Okay, first things first, we'll need to differentiate this function, right? So what is the derivative of our f of x? Our derivative, just grab my trusty pen here. It's gonna be, okay, so f cap of x is equal to 3x squared, right? Plus 2ax, a, right, plus b. The two drops off because it's just an integer. Don't have to explain that again. Okay, so this is what we have. And we know that if we make f of x f of 1, right, we know that f of 1 is equals to 0. We know this, in fact, right, because it's a turning point, so the gradient will be 0. So basically what we're saying is a graph, right? And let's say the graph looks like this, right? We're saying that we know that this point here is minus 3, and we know that this point here, so these are the 2 points, so that this point here is equal to, oh sorry, I'm saying that this point is equal to minus 1, sorry, and we're saying that this point is equal to 3, right? And these are the 2 points, so that our gradient is equal to 0 for the tangent, right? So plus 2a, so this is going to be minus 1 in here, this is going to be a minus 1 plus b. So our first equation will be 0 is equal to, this is squared, so minus 1 squared is 1. So it's going to be 3 plus 3 minus 2a here plus b. Right? And then so the 3 can go that side, and this can become minus 3 is equal to, we can write the b first, b minus 2a, right? Then we'll do the same and try and find out what equation we'll get for when x is equal to 3. So that's going to be 0, right, is equal to 3 3 squared plus 2a multiplied by 3 plus b, right? So it's going to be equal to 27 plus 6a plus b. Right? So this is equation 1, this is equation 2. So we can write equation 2 beneath equation 1 so that we can simplify our two simultaneous equations, right? Is equal to b plus 6a. This is our equation 2, right? How do we solve simultaneous equations? We can solve simultaneous equations by, we can either move 2 here and make b is equal to 2a minus 3, or we can simply try and eliminate the equation. So the quickest way to eliminate the equations would be multiplying equation 2 by minus 1, right? So if we multiply equation 2 by minus 1, this becomes plus 27. So this equation will then change to becoming plus 27 is equal to minus b minus 6a, right? This becomes our new equation 2. Then we say equation 1 plus equation 2. We add equation 1 into equation 2, right? This will be the fastest way to do it. Also 3, right? Minus 3 plus 27 is equal to 24. And then plus b minus b is equal to 0, so we've eliminated b. Then minus 2a plus minus 6a is equals to minus 8a. Right, so to find a, we divide both sides by minus 8, so a is equal to minus 3. Very simple. Right, and then what do we do to find b, right? So we already know that minus 3 is equals to b minus 2a, right? So minus 3 is equal to b minus 3, which is equal to, or 2, sorry, there's a 2 there, is b minus 2 multiplied by minus 3. So minus 3 is equal to b minus 6, or minus plus 6, sorry. So b is equal to minus 9. That is what b is, right? Alternatively, we could have said 2a minus 3 is equal to b, and came in and substituted that here, and it would have been minus 27 is equal to 2a minus 3 plus 6a, right? And then what we would have had, we would have had a minus 27, right? Plus 3 is equal to 8a, which is equals to minus 24 is equal to 8a, and still a would have been equal to minus 3. So either by substitution or by elimination, whichever method you choose, you'll get the same answer. So yeah, that is the basis of it. So question number 1 is done, guys. Thank you so much. It took longer than I thought. It took a whole 30 minutes, most probably because I was explaining more and I'm not just rushing through the questions. I would expect you guys to go way faster than I am and not, take 2 methods to prove. But yeah, it's just good so that you guys understand. Thank you so much, guys. I will see you in the next video for question number 2. Cheers.